Before we begin, make sure you watch this video all the way to the end, because what you're about to discover will completely change how you see galaxies, black holes, and the hidden forces shaping the universe. Imagine a force so powerful it can both create entire galaxies and slowly suffocate them into silence. A force that sits quietly at the center of cosmic cities, controlling their fate over billions of years. That force is a black hole. And not just any black hole, but the supermassive kind, millions or even billions of times more massive than our Sun, sitting at the heart of nearly every galaxy you can see in the night sky. At first, this sounds like a contradiction. Black holes are famous for destruction. They consume matter, trap light, and represent the ultimate point of no return. So how can something that devours everything also play a key role in building galaxies, the largest organized structures in the universe? The answer lies in a delicate and fascinating balance between gravity, energy, and time. To understand this, we need to travel back to the early universe, just a few 100 million years after the Big Bang. At that time, the universe was filled with vast clouds of hydrogen and helium gas. Tiny fluctuations in density caused by quantum variations stretched across space began to grow under gravity. These denser regions pulled in more matter, eventually forming the first stars and the earliest galaxies. But here's where things get interesting. Alongside these forming structures, black holes may have emerged incredibly early. Some theories suggest that massive clouds of gas could have collapsed directly into black holes, bypassing the normal process of star formation. These early black holes would have acted like seeds, anchoring the growth of galaxies around them. As matter began to fall into these black holes, it didn't just vanish quietly. Instead, it formed a swirling disk known as an accretion disk. Friction and gravitational forces heated this material to extreme temperatures, causing it to glow brightly across the electromagnetic spectrum. In some cases, these regions became quasars, among the brightest objects in the entire universe, outshining the combined light of billions of stars. This energy release is where the dual role of black holes begins to reveal itself. The radiation and outflows from these active black holes interact with the surrounding gas in powerful ways. In some regions, the energy compresses gas clouds, triggering bursts of star formation. It's almost as if the black hole is acting like a cosmic engine, fueling the birth of new stars. But that same energy can also have the opposite effect. If the black hole becomes too active, it can heat the surrounding gas to such high temperatures that it can no longer collapse to form stars. In more extreme cases, powerful winds and jets can blow the gas out of the galaxy entirely. Without gas, star formation grinds to a halt. The galaxy begins to age, becoming quieter, dimmer, and less dynamic. This balance between creation and destruction is known as feedback, and it's one of the most important processes in modern astrophysics. Black holes regulate the growth of galaxies, preventing them from becoming too large or forming stars too rapidly. Without this feedback, galaxies might look very different from what we observe today. Now let's zoom in on the structure of a galaxy. At the center lies the supermassive black hole, surrounded by a dense region of stars known as the galactic bulge. Beyond that, spiral arms or elliptical distributions of stars extend outward, along with vast amounts of gas and dark matter. The influence of the black hole is strongest near the center, but its effects can ripple outward across the entire galaxy. One of the most dramatic ways black holes influence galaxies is through jets. When matter falls into a spinning black hole, magnetic fields can channel some of that energy into narrow beams of particles that shoot out from the poles at nearly the speed of light. These jets can extend for thousands or even millions of light years, punching through the galaxy and beyond. As these jets interact with interstellar gas, they can either trigger star formation by compressing the gas or prevent it by heating and dispersing it. The outcome depends on the environment and the strength of the jet. In some galaxies, these jets carve out enormous cavities in the surrounding gas, effectively shutting down star formation in those regions. Now imagine two galaxies on a collision course. Over billions of years, their gravitational attraction pulls them closer together. As they merge, their structures become distorted. Stars are flung into new orbits, gas clouds collide, and intense bursts of star formation ignite across the merging system. At the center of each galaxy, their supermassive black holes begin a slow dance. They spiral toward each other, losing energy through gravitational interactions with surrounding stars and gas. Eventually, they merge into a single, even more massive black hole in an event that releases an enormous amount of energy in the form of gravitational waves. After the merger, the newly formed black hole can enter an extremely active phase. The disturbed gas from the collision feeds it rapidly, causing it to shine brightly as an active galactic nucleus. Powerful winds and radiation can sweep through the galaxy, heating or expelling gas and dramatically altering its future. At this point in the video, if you're fascinated by how black holes can both build and reshape galaxies, take a moment to like the video, subscribe to the channel, and turn on the notification bell so you don't miss more explorations into the mysteries of the universe. As we continue, let's explore the long-term consequences of black hole activity. Over time, many galaxies transition from active star-forming systems into more passive ones. These so-called quenched galaxies have little to no new star formation. Their light is dominated by older, redder stars, giving them a very different appearance from younger, more active galaxies. Black holes play a key role in this transformation. By heating or removing the gas needed for star formation, they effectively shut down the galaxy's ability to create new stars. This process can take millions or even billions of years. But the end result is a galaxy that has entered a kind of cosmic retirement. There are also more extreme events that highlight the destructive power of black holes. When a star wanders too close to a supermassive black hole, it can be torn apart by tidal forces in what is known as a tidal disruption event. The star is stretched and compressed into a stream of gas, which then spirals into the black hole, producing a bright flare that can be seen across vast distances. While these events are relatively rare on a galactic scale, they demonstrate the immense gravitational power of black holes. They are not passive objects. They are dynamic, evolving systems that can dramatically alter their surroundings. Perhaps one of the most intriguing discoveries in recent decades is the relationship between black holes and their host galaxies. Observations have shown that the mass of a supermassive black hole is closely correlated with the properties of the galactic bulge, particularly the velocity of stars within it. This suggests that the growth of the black hole and the galaxy are deeply connected. Scientists believe this connection is maintained through feedback processes. As the black hole grows by accreting matter, it releases energy that influences the surrounding galaxy. This, in turn, affects how much matter can continue to feed the black hole. It's a self-regulating system, a cosmic feedback loop that shapes both the black hole and the galaxy over time. Now let's take a step back and consider the bigger picture. The universe is filled with billions of galaxies, each with its own history, structure, and central black hole. Some are actively forming stars, glowing brightly with new life. Others are quiet and ancient, their star formation long since halted. Black holes are at the center of this diversity. They are not just endpoints of stellar evolution or isolated curiosities, they are fundamental components of galaxies, influencing their formation, evolution, and eventual fate. Imagine looking up at the night sky and realizing that every faint galaxy you see is part of this intricate dance. At their centers, invisible black holes are shaping their destinies, controlling the flow of gas, the birth of stars, and the overall structure of these vast systems. Before we wrap up, I want you to think about this and share your thoughts in the comments. Do you think black holes are more responsible for creating galaxies or destroying them? Or do you see them as something in between, a balancing force that keeps the universe in harmony? As we come to the end of this journey, it becomes clear that black holes are not simply cosmic destroyers. They are also creators, regulators, and architects of the universe. Without them, galaxies might not form the way they do. And without their destructive power, galaxies might grow uncontrollably, becoming something entirely different from what we observe today. If you found this video fascinating, make sure to like, subscribe, and turn on the notification bell so you never miss another deep dive into the mysteries of the cosmos.